we talked about y equals x squared. It was our second graph that we discussed. So this one's backwards from that. It's x is to the first and y is to the second. Normally, the graphs that we discuss are functions. We emphasize the function graphs. We have y equals something, and today's lesson is going to be all about functions, after we finish up these 10 basic graphs. But normally you have y equals something when it's a function, or you can at least solve it for y, and then if it meets the function definition, there's no repeating x, then we call it f of x. F of x is the new notation we're going to use instead of y, the function notation. But anyway, this one is not going to be a function, and you can tell kind of something's up with it because it's written kind of backwards than we normally see. It's x equals y squared. It's still a fine graph, but it's just not a function. So what's something that solves this? 4 and 2, that is true. 2 for y, 2 squared makes the x value equal 4. 4 and 2. Say it again? 0 and 0 works for this one as well. 0 squared is 0. 1 and 1. Okay, 1 and negative 1. Good. You plug in negative 1 on the y side for y. Negative 1 squared makes the x value positive. Okay, what else? 9 and 3 is true. I also want to do 1 and positive 1 to show you how the x value repeats. If you plug in negative 1 for y, it gives you an x value that's 1. Or if you plug in positive 1 for y, 1 squared is 1. So that's that repeating x value I've been telling you about that makes it not a function. So anyway, what it looks like is this repeating sideways parabola. Over 4 up 2, 0, 0, 1 and negative 1, 1 and positive 1, and then 9 and 3. Sideways parabola or a horizontal parabola. And again, a vertical line test, the reason we use the vertical line test is it shows us when you have an x value repeating, one x value with two different y coordinates. So not a function. Okay, it still has a domain and range. The domain, the x values were only positives. Also on the picture, can you see x is only this part of the graph, the positive x values. So domain is 0 to infinity. And what do you think about the range? How low to high does this graph get? Infinity is right. It's going low to high without bound, so the range is everything. Okay, we've already said it's not a function. How about symmetry? Definitely x-axis. This thing folds along the x-axis, matches up perfectly. So really anything that's symmetric with the x-axis is not going to be a function for that reason. All right, number 9. Number 9 is called the greatest integer function. I'll write that down. You may have not used this notation in a different class before, so let me explain what this is. You've got these brackets with little lines, vertical lines in it. That's the notation that means y will equal the greatest integer less than or equal to the input value x. So you may want to copy that down. All right, so when we input numbers for x, such as 1, let's say, we will output, the y will be the greatest integer that's less than or can be equal to that number you put in for x. So when I input 1, 1 itself is an integer. Let me remind you, an integer means no fractions or decimals, just positive or negatives of the whole number. So 1 is an integer. So we can equal an integer. It can just be that output, and that's what it will be. When you plug in 1, you will get 1. When you plug in 2, you'll get 2. so on and so forth. If it's an integer you plug in, it outputs that same integer. You do negatives as well. Those count as integers. Positive, negative, whole numbers. But if we input a decimal amount, like say 1.2, the y answer has to be an integer on the y side, and that's actually going to be the range of it. The output for y can only be integers. Okay, so if we input a decimal or a fraction, something that's not an integer, we'll round it. Basically, that's what this thing is. It's a rounding function. Kind of like if you park in a parking garage and you stay there for an hour and 20 minutes, they go ahead and round up maybe to 2 hours. But the greatest integer function, it rounds down instead of rounding up. You have to stay less than or equal to the number you put in. So if you put in 1.2, you can't round up to 2 because you have to be less than that. Okay, so we're not going to round up, we're actually going to round down. So if we put in 1.2, we round down to the next integer, 1.
So even if it's like 1.9, you round to 1.
Exactly, yeah. Even 1.999, whatever, you will round down. Exactly. Okay, so whatever I'm putting in 1.125, 1.1 whatever, I get the output 1. Whenever I hit 2, I can use 2 because it is an integer. It can be equal to that. So if I input an integer, I output an integer. But if I input, say, 2.1, I round down to 2. 2.2, I round down to 2, and so on. So here's what that looks like on a graph. Let me put in 1, 1, 2, 2, 3, 3. All the integer ones are there. It almost looks like the y equals x graph, except we don't get to connect our dots because it's not climbing that way. What it does is it flat lines between those. So like at 1.1, it's still 1. At 1.2, it's still 1. 1.9, it's still 1. It makes this little flat horizontal line. And then at 2, we put a little open circle down here to show we're getting up so close to that you can't detect it with your eye. So we want just an open circle to say I got as close as I could to 1, but whenever I actually hit, 2, then I jumped up, that 2 should be 2. And then at 2.1, 2.2, all the way over till I hit 3, then it jumped up to 3, 3. So it looks like this little staircasey thing like that. Same story on the negative side. There are little dots with open circles at the other end of it. So the domain, what you can plug in for x was anything, positive, negative, decimal, whatever. Everything goes on the domain, but the range, the output side for this function was just the set of integers. And we're just going to write that out and say it is a set of integers. It is a function, it's in the name, it's the greatest integer function. Also, you can see vertically, it does not repeat. That's a filled-in circle, but that's an open circle, so they're not sharing the same point. So it is a function. The vertical line test works. And it almost has the origin symmetry, but if you turn this around, the open circles will be on the wrong end, so it'll be backwards. It's not exactly the same when you rotate it, so it has no symmetry. I already did 10 on that.